Hello students. So in the last class we had discussed some problems and of course we have discussed all the concepts related to what the friction. Okay, but now guys, we are going to see some more rigorous application of the concepts that we have learned in the friction chapter. So guys, one of the more you can say the rigorous application that we see in general is what it is known as the solving the problems of two block combination. Okay guys, so it is also known as two block problems. Two block problems. So guys, two block problems are one of the rigorous application of what of the concepts that we have learned about the friction. So guys, in the terms of concepts there is nothing new, but yes, of course there are some set of procedures or some set of steps that you should learn or you should know before attempting the problems of the combination of two blocks. Okay, the combination of two blocks. So I'll just write down some steps. Okay, and then we will see some problems directly on the two block combinations. So let me write down guys what the few steps. The first step is guys what the first step 1. Okay, step 1. As we know that the friction acting between two surfaces here, in this case between two bodies always tries to avoid the relative slipping or sliding. So we will assume from our own side that they will move together and no slipping will happen. So we will calculate the theoretical common acceleration on the two block, considering them as a system considering them as a system. So consider them as a system, as a single system. Okay guys, so this is your step 1 guys. Okay, this is your step 1 you can say, and the above whatever I have discussed is just the part of the understanding that why we are considering them as a system. This is the step 1 guys. Okay, now I'll go to the step 2. Okay, so guys, step 2 what it says guys: apply the Newton's second law and write the force equation for this system that we have taken that we have taken okay guys. So this is the second step guys. Okay, this is what the second step. Just let me reduce the sharpness guys. Okay, now guys, after that, step 3 step 3 check the availability of static friction between the two blocks and compare the value of required friction force value to move the blocks together with available friction. This is guys what your step 3. Okay, after that guys, the last step we can say step 4 is what guys? If the F available, okay, if F available is greater than what guys? F required. If F available is guys what? Greater than F required or equal to what guys? F required, then the blocks will move together. Otherwise they will slide. So last step guys. Okay, step 5. If above condition does not get fulfilled, then write down the second law equation for individual bodies and calculate their individual acceleration So guys, that's it. Okay, so the guys, these are the steps we can say that we have to follow to solve any two block problems. Okay, any two block problems guys. Okay, so you can go back and you can watch these steps guys. You can read them once. Okay, you can read them once, and then you can see that how I'm applying these steps in the upcoming problems guys. Okay, so I'll take one problem, and with that guys we will understand that how I'm using the idea. Okay, how I'm using this idea guys. So let me choose some color, okay, which fits. Okay guys, so okay guys, so Okay. Okay guys, so let me start with the guys a very simple question. So problem 1. Okay guys, problem 1. So please pay attention guys. It is very simple, like what we can say, the segment of what the application of the concepts of friction. So just we have to follow the guidelines, you can automatically solve all sorts of problem which will come in front of you. So I'll take a very easy problem guys, and then we'll go one by one what like more difficult problems. Okay, so guys, let's say this is one block, this is another block. Okay guys, both mass is what, 10 kg, 10 kg. Okay, and guys, this is given smooth. Okay, this is given what guys, smooth. And guys, this is given mu is equal to what, 0.5. And they are saying is that on the upper block there is a 50 Newton force is applied. Okay, so guys, what they are saying that between the ground and the 10 kg block, the lower block, okay, I'm calling this one is what guys, block A, and this is what, block B. So guys, block A and between the ground there is no friction guys. Okay, there is no friction. The mu is what, 0 between them. And guys, between the upper block and the lower block, which is what, between B and A, the friction coefficient is given how much guys, 0.5. Means guys, mu s and mu k we will consider is what, same only, and that is what, nothing but 0.5. And they are saying guys that on the upper block we are applying how much force, 50 Newton. Okay, we are applying how much guys, force, 50 Newton. So they are asking what is the acceleration of the blocks. Okay, what is the acceleration of the blocks guys. So how do I approach guys? The first step is guys what, consider them as a what, as a system. Consider them as a what guys, system. And suppose that they are moving what guys, together. Okay, so guys, if they are moving together, what we have to write guys, we have to write down the Newton's second law. That is what, step 2. So guys, to write down the second law guys, what we have to do, we have to see guys, we have to see the net force acting on this body or as a system, okay, which is acting in the horizontal direction, and then we can calculate the common acceleration, which is what, a theoretical acceleration guys. So if I write guys what, A common, so guys, A common will be the net force F net divided by what, mass of system. Okay, mass of what guys, system. So F net is how much guys, 50 Newton divided by guys m of system. Guys, if you see on this whole system only guys, what, in the horizontal direction only 50 Newton is acting, because guys here what, this is smooth, this is what guys, smooth, so there is no friction here. So only guys what, the 50 Newton is acting in the forward direction. So guys, 50 Newton is the net force in the x direction. Okay, and guys, the system's mass is how much, 20 kg. So guys, this is how much, 20 kg, that is how much, 2.5 meter per second square. Guys, this should be what, the common acceleration that is possible if they are moving together. So guys, now let's check that do we have that much friction force available between these two bodies which can help both to move together guys. Now if you see guys, if I ask you, please listen me carefully guys, if I ask you, if this 10 kg block is also moving in the forward direction with acceleration of what guys, 2.5, it needs some force in this direction. Okay, it needs some force in this direction guys. Is there any forces acting on this body? Answer is guys, no. Okay, of course, if it is, there is no forces acting from outerly guys, there should be some force which should act internally. Okay guys, so here who will take care of this guys? The thing is that on this body, the thing is guys what, on this body, if you see the 10 kg, the friction will be acting guys in the forward direction. Okay, the friction will be acting guys what, in the forward direction. And guys, we have to check that F needed is how much. Okay, F needed is how much is, and maybe you might get confused that sir, how you decide the direction in this direction guys. Always remember why what I have told you, my method. Okay, if you remember guys, that how I am right now, I want that you should also become like that only. Okay, how I am right now, I want that you should also become like that only. Okay guys, so if you see here, on this block B, guys, if you see the acceleration is how much, sorry, the force is acting how much, guys, 50 Newton. So guys, it is going to have the acceleration in this direction. Okay, it is going to have the acceleration, guys, what, in this direction. So because it is going to have the acceleration, certain acceleration in this direction, guys, so it will want that you should also have, guys, what, the acceleration in this direction. Okay, and to make it happen, guys, it will apply the friction force on you in which direction, in the forward direction. Okay, so that idea that I have told you, guys, it never get failed, because this is actually the you can say the basic tendency, the natural tendency of what, of the individual bodies. Okay, so guys, this is what the F needed will be acting on this body in the forward direction. I hope you understood. Okay, so now if I ask you, guys, that what is this value that F needed, so guys, of course, F needed, if I ask you, will be how much, guys? F needed should be, if they are moving together, should be what, guys? 10 into the A common, guys, and that is what, nothing but 10 into 2.5, that is what, guys? 25 Newton. Okay, so guys, this is what, this is the needed value of what, friction. Okay, this is what, guys, the needed value of what, friction. So guys, now we have to check that do we have this much friction available or not, like can we provide this much friction if it is needed. So guys, let's see the F available. Okay, F available, guys. So F available will be what, guys, if you see on this system, guys, how much normal force is acting, that is, if you see, that is what, guys, the normal force here is acting how much, the normal force that is acting is how much, guys, that is 100 Newton. Okay, that is what, guys, 100 Newton in the upward direction. So guys, the friction available that you will be having, let me put with some other color, guys. Okay, so guys, if you see, this is what, this is your friction, sorry, normal force available 100 Newton. So guys, the friction force that might be available in this direction or in this direction, guys. Okay, just a minute, guys, in this direction or this direction will be how much, guys? That will be what, guys? Mu into n, and guys, mu is nothing but what, 0.5, and n is how much, guys? 100. So it will be what, guys? 50 Newton. Okay, it is what, guys, available is how much? 50 Newton. It means, guys, what it means, that our F needed is less than what, guys? F available. It means F available can provide this much friction which is needed to move these two blocks what, together. Okay, to move these two blocks what, guys, together. Okay, so very simply, guys, we can say yes, these two blocks will move together, and there will be no slipping between the blocks, and the friction between the blocks would be 25 Newton. Okay, would be what, is 25 Newton. I hope you understood, guys, this first problem. Okay, I hope you understood, guys, what, this first problems. Now guys, we'll move to the what, we'll move to the second problem, problem number 2. Okay, so guys, let me go to the next page only. So guys, problem 2. So we'll take one more problem to understand the, guys, what idea. Okay, so I'll take one more problem, guys. Now guys, suppose in the above question only, okay, if we discuss, guys, okay, in the above question only, if I say that the force, guys, which was acting here is not 50, it is what, guys? 101 Newton. Okay, it is what, guys? 101 Newton. Okay, it is what, guys? 101 Newton. So guys, now if I ask you what would be the acceleration of what, the individual bodies, so again, guys, the same steps we have to repeat, nothing else. Okay, we have to repeat, guys, what, the same steps. If we repeat the same steps, guys, I think we can conclude the answer that what will happen. So guys, let me do that again for you. So guys, if you see, this system has the net force in the horizontal direction is what, guys? 101 Newton only. There is no other force acting on the system externally, guys. Okay, so what we can say, guys, that a common that you will have is what, guys? F external divided by what? Mass of the system. Okay, mass of the system, guys. So that is what? 101 Newton divided by what, guys? 20. So it will become what, guys? It will become 10. 1 minute is 10.1 divided by what? 2, which is what, guys? Which is 5. Okay, 5.5, guys. Okay, 5.5, no, 5.05. Okay, 5 point, guys, what? 05. That would be what, guys? Your acceleration. That would be what, guys? Your acceleration. I hope this is okay, guys. Okay, now now, guys, if you see, okay, guys, so now if you see, guys, what we have to find out, the like can this be done with the friction force or not? Okay, so, guys, if we talk about the friction force, we know that, guys, friction needed, first we have to calculate. So, guys, friction needed will be how much, guys, on the lower block, okay, or block A. Guys, if you see on block A, the force would be acting what, guys? In this direction, you know that. So, guys, we have seen already. So F needed would be, guys, what? Mu into what? Sorry, mu F needed will be what, guys? Mass of the body into common acceleration, guys. So mass of the body is what? 10, and, guys, common acceleration is what? 5.05. So, guys, the force needed is how much? 50.5 Newton. Okay, guys, so F needed is how much? 50.5 Newton. That is needed, that should act on the block A to move these two blocks, guys, what? Together. Okay, to move these two blocks, guys, what? Together. Now, guys, if we remember F available, guys, okay, F available. So, guys, in the just last question only, we have seen that, guys, F available was what? 50 Newton, and that we can just get again, guys, mu into n. Mu was what, guys? 0.5, and this is what, guys? 100 Newton. So, of course, guys, this is what? 50 Newton only. So F available is what, guys? 50 Newton, but, guys, F needed is what? 50.5. It means what, guys? F available is what, guys? Less than what? F needed. It means what, guys? It means the sliding is going to happen for sure. Okay, the sliding is going to happen for sure. Okay, sliding is going to happen for sure, guys, because now F needed is what? F needed is more than the F available. So, guys, in that case, what we have to do, we know that, guys, because now the sliding is going to happen, so we have to calculate the individual accelerations, guys. Okay, so, guys, what we have to do, we have to draw the individual FBDs. So, guys, if you see the lower block, okay, if you see the lower block, which is what? Block A, mass 10 kg, guys, on this, the force of friction will go to its peak only, guys, and that is how much? That is 50 Newton. Okay, that is what, guys? 50 Newton. And, guys, for the upper block, if you talk about, guys, for upper block, the block B, this is also what, guys? 10 kg, and this side force is how much, guys? 101 Newton. And, of course, guys, the reaction pair of this will act on this, guys. So here it will be what, guys? It will be also what, guys? 50 Newton. Now, guys, we can apply the Newton's second law for individual bodies, and we can calculate the acceleration. So, guys, A of A will be how much, guys? That will be the net force on this divided by what? The mass of this. That is how much, guys? 5 meter per second square, guys. That would be the answer of what? The acceleration of block A, guys. In the similar fashion, if we ask you, guys, what is the acceleration of B block, guys? So AB will be 101 minus 15 divided by what, guys? 10. Okay, so that will come what, guys? 51. So, guys, 51 divided by 10, that is what, guys? 5.1 meter per second square, guys. That is what the acceleration of what, guys? Block B. I hope you understood, guys, the idea of what these two problems. Okay, now, guys, I'll I'll change a little bit what the values in this problem, and now I'll make what a bit more conceptual problem in the problem 3, guys. Okay, so let me give you a better problem, guys. Okay, problem 3. guys, I'll make this a little bit more thinner guys. I think just, can we make it custom? I think not sure. Okay, not a problem guys. Okay, now let's see. So guys, suppose this is your ground, okay, and guys there is one block and there is another block, and guys let's say this is 10 kg and this is also what guys 10 kg. This is block A, this is what guys block B, and guys the friction here, okay, the friction here is given how much guys 0.25. Okay guys, and here guys it is given mu s is 0.5 and mu k is what guys 0.4. okay, mu s is given how much guys 0.5 and mu k is given what guys 0.4. now guys the question is here they are asking f minimum, okay, f minimum so that the sliding starts between the blocks guys. okay, so this is the question guys, that what should be the f minimum, okay, means how much minimum force we should apply on the block A in the horizontal direction, so that guys we can achieve what, we can achieve the sliding between the two blocks. okay, we can achieve the guys what, sliding between the two blocks. so guys let's see. okay guys, so it's a good problem now. okay guys, a lot of concepts will be needed in this, and after that I'll discuss one more extension of this problem in this only, and then I think you will get a more clarity about what, that how should we deal with these kind of problems. okay, so guys see, suppose f minimum is what guys f naught. okay, that is what guys f naught that we have to calculate. so guys what I will write, first thing is I'll consider them as a what, as a system guys. I will consider them as a what, system, and assume that they are moving together guys. okay, so I have considered guys block A and block B as a what, system. okay, now guys what I'll do, I'll have to calculate the net acceleration, the A common guys. so A common is what guys, f net divided by mass of the system guys. okay, so guys f net will be how much, if you see on this system guys, now only this f will not act guys, there would be what, the friction force will be also going to act if they are going to slide together. okay, so if sliding is going to happen guys, there is going to be the friction force here guys. so if I ask you guys what would be the friction force value, so guys please listen here. so guys here this friction will be dependent on guys what, this normal force. okay, this normal force. so guys if you have understood the idea of NLM properly guys, so you know that this normal force will be how much guys, this normal force will be 200 Newton. okay, this will be how much guys, 200 Newton. so guys we can say that here, that the force which is going to act guys, okay, that is how much, that is 50 Newton guys. okay, that is what, 50 Newton, which will be going to act for sure if both bodies are going to what guys, move together or not move together. if sliding is going to happen between the ground and this guys, of course this force is going to be what, 50 Newton going to act. okay, so guys what I will write, I will write like this, that f naught minus 50 divide by what guys, m of the system, that is what guys, 20. okay, so guys this is what, this is your A common. okay, this is what guys, your A common. let it be like this way only guys. now suppose guys if these bodies are moving together guys, and if you want guys what, the minimum force so that the sliding just starts, it means guys what, it means that this body will be like the friction between these two bodies, guys, will be what? It's at verge of what? The capacity. Yeah, means it is trying to hold them together so that they will move together. Okay, but guys, if we are going to apply a certain force, after which if sliding is going to just start, it means, guys, what? It means that the friction has gone to its what? Maximum capacity. It means, guys, what? Friction has gone to its what? Its limiting friction value. Okay, it has gone to what, guys? The limiting friction value. It means, guys, what? If we have to analyze the upper body, if we have to, guys, what? Analyze the upper body. So guys, on the upper body, if you see, if this system is moving in the forward direction, it means what, guys? On 10 kg block, the friction force should act as a limiting, and it should act in the forward direction, and that will be how much, guys? That will be mu s into n, you know that, guys. And that would be how much, guys? That would be nothing but what? Mu s is given how much, guys? That is given 0.5 into n will be how much, guys? 100. So guys, it is what? 50 Newton. It means what, guys? It means that the maximum friction would be acting on the upper block, and that would be what, guys? 50 Newton. And at that moment they will be having a common acceleration. It means if you just exceed your value of f naught from this value, what you are going to have from that value, just a little bit more, guys, what you are going to get? You are going to get a sliding between the two blocks. Okay, so guys, we always calculate for what? For the critical value, and then we say that yes, from this, if it is a little bit more than that, you are going to get what, guys? The sliding or something is going to happen. Okay, so here, guys, if you see, if f limiting is what? 50, so guys, the a common that you are going to have maximum possible, okay, is how much, guys? 50 by 10, that is how much? 5 meter per second square, guys. It means if these two blocks are moving together, guys, so the maximum common acceleration that they can have is nothing more, guys, but what? 5 meter per second square. Okay, nothing more but what, guys? 5 meter per second square. So which means, guys, that for the above equation, equation number 1, let's say if I call this as, guys, what? Equation number 1, and this is what? Equation number 2. I can say, guys, that for equation number 1, the a common should be what, guys? 5 meter per second square. So guys, if I write down the equation again, the equation number 1, so f naught minus 50 divided by 20, it should be equal to what, guys? 5. Okay, now just let me solve this value, guys. So f naught minus 50 is equal to what, guys? 100. So guys, f naught should be what, guys? 150 Newton. It means what, guys? That if your f naught is just a little bit more than what, guys? 150 Newton, you are going to have what, guys? You are going to have the sliding between these two blocks. Okay, so that would be what, guys? Your answer. I hope you understood. Okay, this would be what, guys? Your answer. So for you guys, I'm giving you as a what? As an assignment here only, and you can drop your answer in the comments if you get. Okay, that, guys, if the f applied is 200 Newton, then what would be the acceleration of the blocks? Acceleration of the blocks, guys. Okay, so guys, that's it. Okay, that's it for the two block problems. Okay, we have discussed the two block problems. In the next lecture, guys, I am going to take some advanced illustrations on what? On the two block problems, which might include some HCV problems, some erodive problems. Okay, so the next lecture would be totally on what, guys? Some question solving, the problem solving. Okay, and then, guys, I'll cover one more lecture on the three block problem solving, which is in general does not come, we haven't seen this kind of a problems in the advanced or in other papers, but still, guys, the concepts are like very much same for the three blocks also. So we will cover that also, and then that would be what, guys? We can say the end of what? The chapter. Okay, so 2 to 3 more lectures we are going to cover for this chapter, and then we will be done with this chapter. So for the today, guys, that's it. Okay, thank you so much.